Welcome student in Christchurch Convent Digital Classes, subject Chemistry, class 11th. Today we will see about ionic or electrovalent bond. So as we know from Cossel's and Lewis treatment of the formation of an ionic bond, it follows or it states that the formation of ionic compound would be primarily depend on, मुख्य रूप से किस पे निर्भर करता है? First, the ease of formation of positive and negative ions from the respective neutral atom. कोई भी एटम है जो न्यूट्रल है, जिसमें सेम नंबर ऑफ प्रोटॉन और इलेक्ट्रॉन है, उसको न्यूट्रल एटम बोलते हैं। वो कितनी आसानी से धन आयन या ऋण आयन बनाता है। उदाहरण के लिए सोडियम, जिसका परमाणु क्रमांक 11 है, या मैग्नीशियम ले लीजिए, या कोई भी मेटल ले लीजिए। मेटल हैव जनरली टेंडेंसी टू लूज इलेक्ट्रॉन एंड नॉन मेटल like group 17 element have tendency to gain electron. Secondly, the arrangement of positive and negative ions in the solid, that is the lattice of the crystalline compound. As you can see on the right hand side, rock salt structure of NaCl is given to you. In that structure, orange sphere shows sodium ion and sky blue sphere shows chloride ion are arranged in the crystal lattice. So ionic compounds are generally crystalline in nature. They have definite crystalline structure. In class 12 we will see about solid state and the crystal structure. Then secondly, the arrangement of positive and the negative ion in the solid, that is the lattice of the crystalline compound. So the formation of a positive ion involves ionization, means removal of electron from the neutral atom. Here in the equation it is shown by M, capital M, in gaseous state. So what is ionization energy? Energy required to remove one electron from a gaseous atom. And that to the negative ion involves the addition of electron to the neutral atom. So here it is shown by X. So when any atom loses electron, it requires ionization enthalpy or ionization energy. And when an electron, excited electron, accepted by a neutral atom, electron gain enthalpy or release of energy occurs. So loss of electron is oxidation and gain of electron is reduction. So in the formation of ionic compound, redox reaction take place. Now the electron gain enthalpy, it is denoted by delta EGH, is the enthalpy change or the energy change when a gaseous phase atom in its ground state gains an electron. जब वह एक इलेक्ट्रॉन प्राप्त करता है गैसियस फेज का एटम, जैसे कि क्लोरीन एटम कैन गेन एन इलेक्ट्रॉन फ्रॉम सोडियम एटम. The electron gain process may be exothermic or endothermic, means either heat can be released or absorbed. The ionization, on the other hand, it is always endothermic. Electron affinity is the negative of the energy change accompanying electron gain. इलेक्ट्रॉन गेन के समय तो कोई भी रिएक्शन यदि एक्सोथर्मिक है मतलब हीट रिलीज हो रही है, और एंडोथर्मिक है तो हीट एब्जॉर्ब होगी उस रिएक्शन के दौरान. So obviously on the right hand side you can see obviously ionic bond will be formed more easily between element with comparatively low ionization enthalpy and elements with comparatively high negative value of electron gain enthalpy. So group 1 and group 2 metal when react with group 17 member, so these compound are generally ionic in nature. Now other things related to ionic compound, most ionic compounds have cation derived from metallic element. Cation means the ion which attracted by cathode, and cathode is negatively charged, so cation is positively charged. So generally metals which loses electron during a chemical reaction form cation, like group 1 metal, group 2 metal. Group 1 metal लीना की रब से फरियाद means lithium, sodium, potassium, rubidium, cesium, francium. And group 2 metal like beryllium, magnesium, calcium. The ammonium ion NH4 plus ion made up of two non-metallic elements is an exception. It forms the cation of a number of ionic compounds. So ammonium ion is an exception. It is not made up of metal. It is made up of non-metal, but it can form compounds. Ionic compounds in the crystalline state consist of orderly three-dimensional arrangement by Coulombic interaction energies. जितने भी आयनिक कंपाउंड होते हैं उनका थ्री डायमेंशनल अरेंजमेंट होता है कैटायन और एनायन का. स्पेस में उनके क्रिस्टल लैटिस स्ट्रक्चर होते हैं. इन क्रिस्टल का जो स्ट्रक्चर है वो 7 टाइप्स का हो सकता है. This compound crystallizes in different crystal structure determined by the size of ion. और इनके जो स्ट्रक्चर हैं वो साइज ऑफ आयन से निर्धारित होते हैं. देयर पैकिंग अरेंजमेंट, उनका जो अरेंजमेंट है पैकिंग का वो किस तरह से है, एंड अदर फैक्टर्स. द क्रिस्टल स्ट्रक्चर ऑफ सोडियम क्लोराइड NaCl which is also called rock salt for example is shown below. We have already discussed about it. Now in ionic solid, the sum of electron gain enthalpy and the ionization enthalpy may be positive, but still the crystal structure gets stabilized due to the energy released in the formation of crystalline lattice or crystal lattice. For example, the ionization enthalpy of sodium ion which is in gaseous state, formation of sodium atom in gaseous state is 495.8 kilojoule per mole, while the electron gain enthalpy for change in the chlorine atom which is in gaseous state by gaining one electron into chloride ion is minus 348.7 kilojoule per mole only. The sum of the two is 147.1 kilojoule per mole is more than compensated for by the enthalpy of lattice of NaCl solid which is minus 788 kilojoule per mole. Therefore the energy is released in the process is more than the energy absorbed. Thus a qualitative measure of the stability of an ionic compound is provided by its enthalpy of the lattice formation and not simply by achieving octet of the electron around the ionic species in gaseous state. तो सिर्फ ऑक्टेट कंप्लीट करने पर निर्भर नहीं करता है किसी भी आयनिक कंपाउंड की क्रिस्टल स्ट्रक्चर की स्टेबिलिटी. लैटिस फॉर्मेशन में जो एंथैल्पी चेंज होता है उस पर भी डिपेंड करता है. अब सिंस चूंकि लैटिस एंथैल्पी प्लेज अ की रोल इन द फॉर्मेशन ऑफ आयनिक कंपाउंड, हम देख रहे हैं कि आयनिक कंपाउंड के निर्माण में लैटिस एंथैल्पी या लैटिस एनर्जी एक महत्वपूर्ण भूमिका अदा करती है. So it is important that we learn more about it. What is lattice enthalpy or energy change? So as you can see, what is lattice enthalpy? Written in dark bold letter on the left hand side, heading 4.2.1. The lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent ion. So ionic or electrovalent bond is formed by the exchange of electron between two atoms of the two elements. Ionic solid means the crystalline solid which has ionic bond. Generally crystalline solid has one metal and one non-metal, cation and anion, made up of cation and anion. For example, the lattice enthalpy of NaCl is 788 kilojoule per mole. This means that 788 kilojoule per mole of energy is required to separate 1 mole of solid NaCl into 1 mole of Na plus ion cation gas and 1 mole of chloride ion in gaseous state to an infinite distance. This process involves both the attractive forces between ion. Oppositely charged ions have Coulombic attraction force between them, and the repulsive forces between same ions like which are having same charge like Na plus Na plus. The solid crystal being three-dimensional, it is not possible to calculate lattice enthalpy directly from the interaction of the forces of attraction and repulsion. Only factors associated with the crystalline geometry have to be included. So thank you for watching. See you in the next video. In next video we'll see about bond parameters. So if there is a bond, either covalent or ionic bond, there are some important terms related to bond which we'll learn in the next video.